All right. Yeah, good afternoon, everyone. Yeah, I'm talking about code-based growth and the developer productivity impact, and specifically how we make the case for investment in DPE. All right. Yeah, my name is Brian. I'm a staff systems development engineer at Jamf. And what is a Jamf? Most people ask me. Jamf, our mission is to help organizations succeed with Apple. So we make a variety of IT management software and solutions to manage and secure Apple devices, basically at organizations at any scale. We also have a lot of cool engineering problems that we're solving, and we write about them on our engineering blog. So check it out, engineering.jamf.com. And today I wanted to tell a little bit of our story in the hopes that it would inspire and give you some tools if you're in a similar situation as ours with growing code bases, large code bases, relatively large. There have been some huge code bases that we've seen so far today. But how you can make the case for investing in DPE. We're taking a look today at Jamf Pro. Jamf Pro is our oldest and largest product. It's a mono repo. We've got 1 million plus lines of production code in the repo, 150 engineers actively contributing. Now, this is a totally different scale from 4,000, 6,000, 40,000 engineers, right? But these techniques, they work at any scale. So we're looking at about 28,000 CI builds over the past year, and our average build time is 23 minutes. Our stack is fairly standard. We've got a Java server backend, TypeScript front end. We're building the whole thing with Gradle. And our code base, like any active code base, is growing over time. So our lines of code count is, over the last 4 years, it's growing at a pretty steady rate. And something that I think is not recognized or discussed enough in engineering, in planning in particular, is that as the code base grows, your build time is going to grow at the same rate, roughly. Your build and test time is going to grow along with your code base. And so if you have a bottleneck with build and test time right now, well, I can guarantee you in 3 years, 5 years, it's going to be twice as bad. So in 2019, it was a big year for us in DPE at Jamf. We hired our first full-time engineer to focus on DPE initiatives with Jamf Pro. Our build times were around 45 minutes, and that was pretty painful. So we hired an engineer, and we also brought in Gradle Enterprise to help us do some build acceleration. And starting out 45 minutes at the start of 2020, and our build times have gone like this. So this is not a big bang. Oh, we saw a 90% decrease in build times out of the box or as soon as we started doing this, but we've been able to make incremental improvements, and right now we're sitting at 23 minutes, which is half the time that it was 3 years ago. And that's significantly different from if that build time had continued on the same trajectory as the code base. We're looking at 65-minute plus build times. So just a little bit of the history in 2020, using data from Gradle Enterprise, we were able to make the case to migrate from Maven, our existing build tool, to Gradle and implement build caching. And we got some good speed up out of that, about a 10-minute drop in the build time, primarily from the build cache. And then fast forwarding a little bit, 2020, our build times were at 30 minutes, and we're still looking to accelerate. 30 minutes is a long time to wait. There's a lot of context switching that happens when you're waiting for 30 minutes of a build. And predictive test selection and build cache optimizations were the two key things that we focused on in 2022. And we were able to drop the build times down to 23 minutes. Zooming in on that, lines of code grew 11%, double digits, same for unit test, integration test even a little bit more, build time down 23%. So that's 35% better than just growing at the natural rate. If the build times and test time grew double digits along with the code base. So how we did it, predictive test selection, build cache optimizations. So I love this principle from the Agile Manifesto, simplicity, the art of maximizing the amount of work not done is essential. And both of these techniques, both of these tools play right into that principle. With predictive test selection, it's a tool built into Gradle Enterprise, now Develocity. that uses machine learning algorithms to intelligently run only a subset of tests that's going to be necessary to still give you high confidence in a particular change. Because with Gradle as the build tool, you know the inputs, you know the outputs, and you know the test failures as well. So it enables us to filter down to only a subset of the tests. And last summer, 2022, we did a proof of concept, and then we rolled it out to the full test suite in October. Now, what this does is we're getting the savings from the predictive test selection on all of our dev branches, and then we run on our main branch, we still run all the tests to make sure that we're not losing any code coverage, and it just as that safety net in case any test failures do slip through that predictive test selection didn't select for on the dev branch. And something that was really cool, really mind-blowing to me was that the implementation effort was really minimal. It was only a few hours, and I'm talking like less than 10, maybe 7 or 8 hours to implement the whole thing. And it was just looking at the simulated test dashboard to ensure that the test accuracy was still what we were expecting, and it was still 99+%. And here are our results. After 6 months of having predictive test selection implemented, this is back in March, we were saving 36% of unit test execution time, 39% of integration test time, 111 days of build time saved per month, which for our smallish team, that was pretty significant. Let's fast forward to today. I was just putting the slides together for this last week and went to look at the latest numbers. And after 1 year, I didn't actually realize this until I was doing the slides, but we're actually saving 80% of our total test execution time as the machine learning algorithms have gotten better and have learned on our test suite. We're now saving 93% of unit test time, 64% of integration test time, and 165 days of build time saved per month. So what about uncaught test failures that slip through to the main branch? Well, in a year and over 2,000 merges to the main branch, we've seen exactly 3 test failures that slipped through, and they were all easily recognizable and easy to fix right away. The developer time and cost savings. So Gradle Enterprise uses an ROI calculator, and in it there's an assumption that developers are actively waiting on about 20% of builds. And internally, that's about what we've seen as well. If we take that 20% of builds and multiply that by the time that we're saving, we're looking at 33 days saved per month, and that turns out to extrapolating 1.5 engineering years and the associated cost saved per year. There's also some savings on the CI agent side. This is much easier to quantify. It's hard numbers. You're not making assumptions about how much time are people waiting. Just running on Amazon EC2 agents, we're saving $9,000 a year. Small change, but it's not nothing. It's actually greater savings than the cost that it took to implement it. This is our predictive test selection dashboard. So we're saving 291 days over the last month. And because of how we run things in parallel, that number works out to about the 165. The build cache optimization, making tasks cacheable and keeping the cache misses low. In 2022, we fixed cache misses for a couple of long-running test suites, and that really got us some speed up. The cache hit rate is 98%, and the time that it has taken us to maintain and optimize the build cache this year was about 1 engineer for about 2 weeks. And our build cache avoidance savings right now is sitting at 60% for Jamf. So 60% of all build time is being avoided just through our build cache. It's build cache optimization, it's the dashboard is showing that. So what's the ROI? Is it really justified to invest the money in these techniques? Well, as engineers who are feeling the pain of long builds, long test times, you intuitively know, yeah, let's do something to make this better. It's going to pay off, but let's take a look at it. So in the alternate reality where we weren't doing any build acceleration techniques, just without PTS and build cache, our CI builds are averaging 65 minutes. And that works out, doing some math, to 3 engineering years lost per year on a team of 150, and it's closer to probably 100 developers who are working on it daily. So that's 3%. That's 3 engineers worth of time that's just lost, wasted, gone. But the real world savings, if we take a look at where we're at today with 23 minutes, 23 minutes is not the end game. We've got a long way to go still, but we're only losing 1.1 engineering years lost waiting for builds. So you say that the techniques are gaining us 1.9 engineering years per year. And to maintain this going forward, our estimate is it's about 10% of a full-time engineer's capacity to maintain both predictive test selection and build cache. I would say that's even very generous. It's probably much less than that. But still, using the generous estimate, that's a 19x ROI. So what's next? We've got some more stuff that we're working on right now and that we are looking at in the future. And for each one of these things, when we write up the initiative, we include some of these calculations. This is our current state. This is where we're looking to go. And here's how much we have calculated that this will save us as an engineering org. And that's really helped us in making the case for management, especially to get these initiatives prioritized. So some of the things that we have in progress right now are test distribution, where we've rolled it out for unit test. We're seeing some great results from that already. Integration tests are a harder problem, mainly because our test suite, the tests need to be better isolated, but that's what we have in progress right now. And also configuration cache, we have work going on right now. The IDE revamp we have estimated is going to be like a 10 engineering year per year savings so that's another huge thing we have coming. And then also we want to roll out the success that we've seen with Jamf Pro. And we have quite a few projects at Jamf that are already using Gradle Enterprise, but now we want to standardize and make that available and used across all Gradle projects at Jamf. Similar to what Henry was talking about from Apple, having the custom distribution, rolling that out to every project automatically. That's the project that we're working on now and coming up over the next few quarters. So tying this back to the developer experience impact, because that was my passion. The developer experience, I've suffered a lot of pain waiting for inefficient tools and slow builds and tests in the past. And that was what got me into DPE in the first place. And without any build acceleration features, developers on Jamf Pro would be waiting an average of 5.2 days per developer per year. That's a week lost, just spent sitting watching builds. Not only is the waiting time lost, but the additional developer productivity, because you break the mental flow, your context switching, and the frustration that comes with that, not to mention just the lost innovation. It's much harder to quantify, but it's real. And our philosophy is happy developers are creative, innovative developers. And these techniques, investing in DPE has helped us make the engineering experience a little bit more awesome, one step at a time. That's all I've got.